Hi, I'm back with another video segment. Assalamualaikum and very good day. Today, my new team will be presenting about Superheterodyne receiver. Without further ado, we go for the first presenter, Tengku Nur Isati.
I want to explain about problem statement and objective. Problem statement. There have been high rate of interference between radio stations due to the recent increases in the number of radio stations. This interference leads to poor sound quality of a simple AM or FM receiver. Research has shown that the use of wrong component and poor IC are the causes of this interference and other drawbacks of a receiver system. These drawbacks include but not limited to cross modulations, local oscillator radiations, and blocking. The problem statement of communication technology. Most of the functions in a superheterodyne receiver were implemented using analog circuit. This has several limitations. First of all is such a system was not reconfigurable. Any modification was possible only through physical interventions. Secondly, complex communication algorithms were difficult to implement in the analog domain due to the size of the component, associated costs and power consumptions, which increase in speed of data converters and signal processor. It became possible to implement analog functions in the digital domain. Lastly, the component requires a difference capacitor for each waveform involves design problem. And for the objective is first is to eliminate this problem by introducing a TDA 7000, which is a simple modulating integrated circuit. TDA 7000 contains all the stages of FM superhead, for example the RF input stage, mixer, local oscillator, FM amplifier, bass demodulator, mute detector, and mute switch. This will equally propose the use of CN414ZIC for the design of AM radio receiver. Second, to optimize for low power consumptions and minimum external component with the operating frequency of 88 MHz to 108 MHz and 550 kHz to 1600 kHz, which cover the standard FM and AM bands respectively. The single chip receiver also eliminates the drawback of the regular receiver, which good selectivity, sensitivity, proper intermodulations, IM, rejections, and audio amplifier. Third is the design and implementations of the circuit design and performance evaluation of the superheterodyne FM or AM receiver using multi-SIM software.
Thank you, Tengku. Next, I will go through what we do along this mini project. First of all, of course, is a briefing first. How do we know to do without it? Next, we're planning and choosing suitable journal for this project. Then we summarize it and dividing role. On 18th December 2020, we submit the first phase of report and we continue the second phase, which is adding and editing the report by using IEEE formatting. Lastly, is video presentation. That's what we do from start to the end. For the next presenter, I will call upon Nofatin Wahida to present.
So I will present my part, which is literature review. In radio transmission, a radiating antenna is used to convert a time-varying electric current into an electromagnetic wave, which freely propagates through a non-conducting medium such as air or space, and is nothing more than a device built to produce a dispersing electric or magnetic field. Next, the radio frequency spectrum encompasses an extremely wide frequency range, and both natural radio frequency energy created by lightning and planetary storm, as well as radio frequency generated by man for communication, entertainment, radar, and television. For topic Superheterodyne FM receiver design and simulation, states that there are two types of radio receiver, which is single carrier and multi-carrier. For single carrier, receiver is a traditional radio receiver deriving selectivity and analog filter of the IF stage. Multi-carrier receiver process all signal within the band with a single RF or IF analog chip and derive the selectivity within the digital filter that follows the analog and digital converter. Next is about the carrier benefit. The multi-carrier receiver outweighed of a single carrier because it can be applied to design a smaller system that a reduced cost due to elimination redundant. Next is about telecommunication engineering. Said that extra function of different block of a superheterodyne receiver. Okay. The author discussed some of the parameters of a receiver system such as interference, sensitivity, and as shown here. According to this, interference occurs as a result of another signal with a same frequency being received by the receiver at the same time and the wanted signal, which cannot be removed by the receiver itself. Okay, inside the literature review also, there are a type of AM receiver. AM receiver is classified into six types, based on type of predetector use, such as crystal receiver, regenerative, super regenerative, tune radio frequency, superheterodyne, and synchronized receiver. Crystal set is the simplest form, which employs a crystal such as galena from detector, and its demerits include poor sensitivity and selectivity and low output. In a regenerative receiver, a negative resistance is introduced into a resonant circuit tuned to frequency of the signal being received. Okay, the basic principle of tuned radio frequency receiver is that all RF stages are simultaneously tuned to receive frequency before detection and subsequent amplification of the radio signal. So in reflect receiver, the same amplifier is used simultaneously for pre-detector and post-detector amplification, thus simplifying the design of the receiver.
Thank you, Aida. For FM Methodology, represented by Sharvani and Pavitra. Let's go.
Methodology discussion on the report of Superheterodyne FM receiver using Proteus. Due to Proteus software cannot add IC3DA 7000, we decided to explain project reports. So the title of the project report is Design and Development of a Superheterodyne Frequency Modulation Radio Receiver using IC3DA 7000 in between the range of 88 MHz until 108 MHz. First, the introduction. Tests of reception of signal were carried out in 3 different areas of Lagos State to determine the level of signal reception, and striking results were obtained in Ibeju Lekki and Ikorodu, but fairly results were obtained in AP area due to the topographic nature of the area. This design finds its usefulness in rural areas where there is no access to television sets in order to disseminate information about the happenings in the country. So this is a simple block diagram for a superheterodyne FM receiver. The design work is in 3 stages, namely power section, frequency modulation section, and audio section. Firstly, power section. This is the complete power circuit for frequency modulation receiver. The power section consists of a step-down transformer, which is used to transform the voltage from 230 volt to 12 volt. The output is fed into a bridge rectifier, which is made of 4 diodes to rectify the 12 volt AC to DC. The output rectifier circuit is to fed the smoothing circuit, and the output of the filter is the input to the voltage regulator, which is made of LM7809 CT transistor to regulate the voltage 9 volt constant output, which is used to drive the whole circuit and also used to charge a 9 volt battery, which will be used to power the circuit when the main fails. Also, LED was connected to the power circuit in form of an indicator. Next is FM section. This stage is in 3 phases, which includes the tank circuit, oscillatory circuit, and were built separately, added to the integrated circuit to complete the FM stage, both the tank circuit and oscillatory circuit, which depends on the values of the inductance. This is the diagram of tank circuit, and this is the oscillatory circuit. There are some calculation of frequency range for the receiver. From the circuit, we have number of turns equals to 3 turns, and it consists of radius, length, and minimum variable capacitor, maximum variable capacitor, and also variable capacitors. These are the calculations to identify the minimum and maximum frequency that can be obtained. So the minimum frequency is 88.3 megahertz, approximately 88 megahertz, and the maximum frequency is 108 megahertz. So it can be reduced at the frequency at the oscillatory circuit at 88 megahertz until 108 megahertz. This is the complete diagram of the FM section with TDA 7000 IC. Next is audio section. Audio section is responsible for amplifying the sound, which consists of various capacitors, resistors, 2 buses, and also IC TBA, which is responsible for amplification. This figure shows complete circuit diagram for the audio amplifier section. Next is the complete circuit diagram of FM radio receiver, which consists of the main component TDA 7000. Lastly, the discussion of results. At Ikorodo area of Lagos State, it was observed 14 stations were picked by the designed FM radio with frequency range between 89 MHz at 25 km to 102 MHz at 18 km. When I compared to the theoretical calculation and the practical, is both are same. So after much research and studies on this paper or this report, conclusion can be made that superheterodyne frequency modulation receiver using an integrated circuit TDA was successfully achieved.
Hi, I'm Pavitra from RK20 and I'm going to talk about the methodology for superheterodyne FM receiver using multi-SIM software. The goal of this research work is to model and simulate a superheterodyne FM receiver using TDA 7000, which is a simple monolithic integrated circuit. Unfortunately, we couldn't come up with the simulated superheterodyne FM receiver using multi-SIM software because 1. We couldn't find the PSpice model for TDS 7000 in the Google. To be honest, there is no PSpice model available in the Google for TDS 7000 IC. Next, there is no exact pin configuration available for TDS 7000 IC in the Google. So, without the exact and confirmation, we couldn't we couldn't create a TDS 7000 IC in the multi-SIM. Next, here is the block diagram, complete FM block diagram of the receiver. So it starts off with the antenna, sends signal to the RF section, mixer, IF section, detector, and finally to the audio section. And the output will be out through the speaker. So let's look at the TDS 7000 IC pin configuration. This IC consists of 20 pins, and it's actually a circuit, a simplified circuit which has IF circuit and demodulator circuit, correlator circuit, tank circuit, oscillatory circuit, and so on in it. It's a simplified yet complex circuit, complete IC to be created in the software. So we will look at the next, which is this is the FM tank of TDS 7000 IC, which is connected to the pin 13 and 14 of the IC. And this is the FM oscillatory circuit, and this is connected to the TDA in the pin 5 and 6. And these are the following calculations for the oscillatory circuits where we will find the maximum frequency. And this is the final audio amplifier circuit, which has the speaker as an output at the end. Uh, the two major components we use here is TL071ML and LM386. So finally, this is the complete circuit of the FM Superheterodyne FM receiver using TDA7000 IC. The output from the last stage of this circuit is in the pin 2, which is fed in the audio section and finally to the speaker. And finally, this is the input waveform of FM receiver amplifier. And throughout this discussion, what I would like to say is, it can be seen from the graph that a small audio frequency will produce an output with 3 times of that input. The results obtained above show how the design receiver has been able to overcome some of the drawbacks of the regular receivers with improved functionality based on the IC used in the design. So, thank you.
Thank you, Sharvani and Pavitra. And for AM methodology, I'm return back to Wahida and Tengku to present.
Hi, so this is a design for AM tank and auxiliary circuit. This is achieved by the use of SA612A IC. This IC is double balance mixer and oscillator. The RF input in pin 1 and 2 is biased internally. They are symmetrical. The mixer output at pin 4 and 5 are also internally biased. Each output is connected to the internal positive supply by 1.5 kilo ohm resistor. This permits direct output termination, yet allows for balanced output as well. The oscillatory pin is connected in pin 7 and 6. So when I do simulation for this circuit, so this is the output for time base 1 second, and this is when and this is the value when we move the cursor. So this is basically how AM double balance mixer and oscillator looks like.
For the audio or amplifier, we have two circuits. First is FM audio amplifier and second is AM audio amplifier. For the FM audio amplifier, is designed with the two IC operational amplifier TL071 as the preamplifier and SA612A IC circuit. The TL0741 is exactly the same as the more famous 741. The only difference lies in the fact that TL071 has the FET on its input and 741 the bipolar transistor. And let's see the circuit. For the amplifier, pin number 3 is negative, is connected to the R1 resistor and C2 capacitor and is connected to the function generator. And for the positive, pin number 3 is connected to the R2 resistor and function generator input is connected to the functions oscilloscope is connected to the function generator input and connected to the C2 capacitor. And after we finish construct the circuit, we generate the output waveform, and it will appear as a sine wave waveform like this. And for the AM audio amplifier, we have MC458CG and a negative amplifier. Pin number 2 is connected to the R2 resistor and C1 capacitor and connected to the ground. And for the positive, pin number 3 is connected to the R1 resistor and C2 capacitor and connected to the input oscilloscope. And for the pin number 1 is connected to the transistor Q2 and transistor Q4. And after we finish construct the circuit, we run the circuit and the output waveform, sine wave waveform, is appear like this.
Thank you, Tengku. Lastly and not least, I will call Wahida again to present for the implementation.
For implementation, analysis and result for AM, so this is the design complete AM receiver. Here we have two oscillator, and this is the antenna, telescopic antenna. Actually, the design of the telescopic antenna is different, but this is the sample, but their function is same. And next, the station signal is from this telescopic antenna lead to the double balance mixer to this IC, which is tank circuit and oscillatory circuit. So inside this IC, the signal are mixed with the modulating frequency, which is the intermediate frequency. The output is fed into one for one IC, which has the reception bandwidth from 150 kHz to 3 MHz. So the local oscillator, which is tuned to station frequency, is also designed to have reception bandwidth from 550 kHz to 1700 kHz. If the IF amplifier then amplify only the signal equal to the intermediate frequency, followed by the limiter, the FM detector, and the LF pre-amplifier, the output from the last stage, which is pin 7, which is fed in the audio section, and finally to the speaker. When I simulate this circuit, this complete AM receiver, and we can see this first simulator at first oscilloscope. Okay, this when we use time base 1 second, and here we adjust the channel to look this become smaller, and we can see the output here. I mean the reading of this sine wave. So this is for first oscilloscope. For the second oscilloscope also, this is the output sine waveform when we use 500 millisecond. Try to change it into 1 second per same as this one. This channel A we use for 20, and this oscilloscope 2 we can see the output for both channel, which is channel A and channel B.
Thank you, Wahida. For the end of implementation, that will end this our presentation today. That's all. Assalamualaikum and goodbye. Wait a second. Before that, don't forget